I now want to look at different variations on my graph of y equal to sine of x, different things we can do. The first thing I want to look at is y equal to a sine x. What happens when I multiply sine of x by a number? Here I have my graph on Desmos, and I have this slider here for a. And if I move it, I can see what happens when I multiply sine of x by a number. A number bigger than 1, we can see essentially kind of stretches it out vertically. If I use a number between 0 and 1, you can see it kind of shrinks it vertically. And if you were to use a negative number, it flips it around the x-axis. A negative number between 0 and -1 is going to flip it and shrink it vertically. A negative number smaller than -1 is going to flip it and stretch it vertically. So instead of saying the range is between -1 and 1, it's actually between negative absolute value of a and absolute value of a. Since this is going to change the values of the range, it's going to change the height of those peaks. The absolute value of a is known as the amplitude of the sine function. It tells us the height. It tells us the highest and lowest points, and it is known as the amplitude. Now that we know what happens when I multiply by a number out front, what if I multiply x by a number? A times sine of bx. And I'm going to specifically look at the case where b is greater than 0. I do not want to consider a case where b is negative. So if I start changing this value of b, we can see it's going to change the period. It's going to kind of shrink in and cause this graph to repeat more often. If I change it to a number between 0 and 1, it's going to stretch it out and cause it to repeat less often. So multiplying x by a number changes the frequency, or how often we see this thing repeat. It changes how often we see our period. The standard period of sine of x is 2 pi, but in this case our period actually changes to 2 pi over b. That b value is going to change the value of the period of the function. Next, let's look at a sine of bx minus c. Let's see what happens whenever I subtract something from the x value. As I change the value of c, it's going to shift my graph to the right for positive values of c, or to the left for negative values of c. So changing this value that I subtract from bx is going to shift my graph. This change is known as the phase shift, and it's defined by c over b. And what the phase shift tells us is it tells us where a period starts. So it tells us where that first period actually begins on our sine function. Finally, let's look at what happens if we add a number to the end. Instead of adding a number inside of the sine function, what if we add it to the end of the sine function? As I add a d to the end, it's going to shift this graph, either up if d is positive or down if d is negative. So adding a number to the end is going to change that vertical shift of the graph and affect the range as well. This value of d is known as the vertical shift. And when I have a vertical shift, it does affect my range. Instead of between -1 and 1, we have that the range is between d minus the absolute value of a and d plus the absolute value of a.